Hey you guys, I hope this unit is going well for you so far. I just wanted to make a video going through some examples. Sometimes these rational exponents can seem fairly tricky when we're first learning them, but really it's just a couple of quick tricks really that help us to work these out. So I hope these examples are helpful, and let me know if you have any questions. For these questions, they are currently in radical form, and radical form means that there is a square root, or maybe a seventh root in this particular case, or a root, or in this case a ninth root. In this case there's a sixth root. So radical just means some kind of root is going on. And what we want to do is we want to write them in exponential form. And exponential form is taking any value and then raising it to some power. So that's exponential form. Okay, so for example 1 here, let's think about this x on the inside. So it's just an x by itself, but that's 1x, or really it's x raised to the first. And when I write something from radical form into exponential form, what I do is I keep the exponent that was attached to the variable, and the number that's outside this radical, 7 in this case, is going to move all the way to the denominator of the original exponent. On this next one, I have an a on the inside, so that's technically an a to the first. Okay, so I have a and then raised to the first power. And then I'm going to go ahead and take this number that's outside of the radical, and it does have kind of a special name. It's called the index. So I'm going to go ahead and take that index, and I'm going to bump it to the denominator of that fraction. So this is going to be 1 divided by 9. So that's a raised to the 1/9. And I might even rewrite that. And I don't really mind that it looks kind of like that, and I need to fix it, because that's a nice clear point that I want to make, is to make sure that that looks like an exponent. So we need to make sure that we know that it's not a times 1/9 or something like that. It's not multiplication. It's an exponent. So it needs to be clear that it's being raised to that fractional exponent. Okay, this last one here, I already have my exponent written there as b to the fifth. So I could start with b raised to the fifth power. And then this index here is 6, so that's going to go ahead and move to the outside, and it's going to bump and be on the denominator of that fraction. So that's going to be b raised to the 5/6. Here we're going to be going the reverse direction. So the problems that we're starting with are in exponential form, and we're going to rewrite them in radical form. And to do this, I'm going to think of what is my base, x in this case, and what is the numerator of the exponents. And that numerator of the exponent is going to stay exactly where it is. And this denominator of the exponent, I'm going to kind of reverse what I did on the previous examples, and it's going to travel backwards out here, and it's going to be my index. And remember, the index is kind of the name for the number that is outside the root right there, or telling me what root I'm taking. So I'm taking the 6th root of x to the first in this case, and since x to the first is really just x, then we could write it as the 6th root of x. All right, next example. Here I have x raised to the third. So I'm going to go ahead and keep that numerator exponent, x raised to the third. And then that denominator of the exponent is going to travel around to the outside. So that's going to be the 8th root of x to the third. And this last example, before I get too excited and go to town bringing that 20 to the outside, I'm going to think about that 4 divided by 20. And 4 divided by 20, well, doesn't that simplify? So they're both divisible by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. So now I simplified it, and I can go ahead and keep that numerator exponent just where it is. So I have x to the first. And then that denominator exponent is going to travel to the outside of the radical, and it's going to become my index. So now I have the fifth root of x to the first. And that x to the first, well, that's just really x, so I don't really need that. So there's my answer right there. Here we're going to talk about, well, what if we have a fraction that I'm raising to an exponent? So in example 7 here, we have 5 divided by 4 raised to the second. And do notice how that 5 over 4 is in parentheses. And so since it's all in parentheses being raised to the second, that means everything in this parenthesis is being raised to the second. So one way to think about it is maybe think, well, squared really just means repeated. So that means 5 over 4 times 5 over 4. And I could think of that and I could say, okay, well, that's going to be 5 times 5 is 25. And then 4 times 4 is 16. And then that's my answer. And then we can also just kind of think of it a little bit more directly, straight up from this example here where we started. And that squared, that exponent, is going to apply to both the numerator and the denominator. So now that's going to be 5 squared, which is 25, and then 4 squared, which is 16. So either way you think about it will work. All right, let's go ahead and check out this second one here. And here I have a fraction that is raised to a fractional exponent. So we've got fractions going on everywhere. It's looking a little bit crazy. Okay, but let's go ahead and think about our rule here. So we had a rule that said, well, if you have something raised to a fractional exponent, then start off by taking that thing raised to just the numerator first. Okay, so what's the numerator? 1. And then that denominator is going to travel to the outside of the radical. So that denominator is going to travel to the outside of the radical. And here we kind of have some interesting things. So first of all, that 36 over 16 raised to the first, well, isn't that just 36 over 16? Okay, and then also if I'm going to be taking the second root, well, the second root is really just the square root. So the second root is the square root, and we don't need to write the 2. Just the same reason that we don't need to write the 36 over 16 to the first, because that's just 36 over 16. All right, and now I'm just going to be taking the square root of each of them. So the square root of 36 is 6. Go ahead and come down here. And then the square root of 16 is 4. And that's my solution. All right, our last example here is somewhat similar. So I'm going to go ahead and take my base, which is a fraction. That entire fraction is my base. And that's going to be raised to a fractional exponent. So what I'm going to do is I'm going to take this base, and this entire base is going to be raised to the first. Then that denominator of my fraction is going to become my index. So that's going to become the outside of my radical. So now we have 27 over 125 to the first. Well, that's just 27 over 125. And I'm going to be taking the cube root of everything. The cube root means I need to know what would I multiply by itself 3 times to get to that number. So when I'm asking myself, what is the cube root of 27, I'm really saying what times itself 3 times would get me there. Well, let's try 3. 3 times 3 is 9, that's 2 3s. 1 more 3, a third 3, 9 times 3 is 27. So therefore, 3 times itself 3 times would be 27. So the cube root of 27 is 3. Okay, same thought process for that denominator. I'm going to be taking the cube root of 125. What number multiplied by itself 3 times gets me 125? How about 5? Let's try it. 5 times 5 is 25. 25 times 1 more 5 would be 125. So 5 times itself 3 times gets me to 125. Therefore, the cube root of 125 is 5, and my final solution is 3 divided by 5. Finally, we're going to take into account negative exponents. Okay, negative exponents can be tricky for a lot of people. So you essentially just need to remember the basic rule for negative exponents. And the basic rule for negative exponents is to take your base. In this case, I made that 3 over 1, so my base is 3 over 1. So we're going to take our base and then take the reciprocal. You could say refliprical because you flip it. So take the reciprocal or refliprical of the base. So instead of 3 over 1, I'm going to take 1 over 3. And now I'm going to raise it to the positive exponent. So now I have 1 squared, which is 1, 3 squared, which is 9. So one more time, here's how that rule goes. If you have a negative exponent, then what you do is you take your base and you flip it and then raise it to the positive exponent and you have your answer. Notice that even if it's not a fraction to start with, you can make it into a fraction. All right, let's go ahead and do number 11 here. So again, the whole reason that I need to do something kind of funky is I have a negative exponent. And with a negative exponent, our rule is to take the base, which is 1 over 3, and flip it to get 3 over 1 in this case, and then raise it to the positive of that exponent, so the positive third. So now I have 3 to the third. That's 3 times 3 times 3. So 3 times 3, 9, times 1 more 3, 27. And then here that would be over 1 cubed, which is 1 times 1 times 1, which is 1. And then, okay, so we have 27 over 1. Well, 27 over 1 is just 27. So I'm done. That's it. All right, example 12. Again, I have this negative exponent going on there. So the rule for a negative exponent is to take your base, 16 over 9 in this case. So I'm going to take that 16 over 9, I'm going to flip it to be 9 over 16. Now I have 9 over 16 raised to the positive exponent, so raised to the positive 1/2. All right, so I took care of the negative thing, so that's done, that's good. Now I still have a fraction raised to a fractional exponent. So now we need to remember the rule for the fractional exponent. Okay, well that means I need to go ahead and take my base and raise it to the numerator of the exponent. So that's going to be 9 over 16 raised to the first. And then that denominator of the exponent is going to travel to the outside. And that denominator is going to travel to the outside and become my index. So really I'm going to be taking the second root of 9 over 16 raised to the first. All right, let's simplify it a little bit. So first of all, 9 over 16 raised to the first, well, that's just 9 over 16. And then the second root, remember, is really just the square root. So, and then the reason that the second root is the same as the square root is because the square root is really asking the question, what times itself twice gets me to that number? And that's why it's really the second root. Okay, so what's the square root or the second root of 9? Well, 3, because 3 times 3 gets me there. Okay, square root of 16 is 4, and there's my answer, and we're looking good.